So our review number 8 for summative number 8 in the spring semester. My third hour class is helping us with some answers here, guys. So we're looking at our all the A's on this packet, and we are subtracting or adding fractions together. Remember, you guys have a yellow card that shows you steps on what to do when you're adding and subtracting fractions. So I believe the first step says look at your denominators and see if anything can factor. So I look at my denominators, which is awesome because they have the same denominator, but they're not factorable. So what I'm going to do is where I'm going to write my answer, I'm going to go ahead and write that common denominator down in the denominator, and now I no longer have to think about it ever again. Notice I only wrote it one time. It is the common denominator, so you write it once. And then we simplify. So we are supposed to be subtracting 19x minus 8x, but be careful, you're subtracting this 9 as well. So the second to last step on the adding subtracting steps on that yellow card says to simplify your numerator. We're going to combine these x's together and get an 11x, still minus 9, over that common denominator. Now remember, 11x minus 9, that's a number. 5x minus 1, that's a number. If they're not the same, you can't cancel them. So we're going to keep that as our answer. All right, I'll save 1b for you. You guys can try that one. Let's look at 2a. So this time we do not have common denominators. I have an x and I have an x minus 7. So your job is to start listing out things that you need in your common denominators, basically a grocery list of everything you see in the denominators. So we need an x and an x minus 7. So this fraction, in order for it to look like this, is missing the x minus 7. And then this fraction, in order to look like this, is missing the x. So you don't have to do any work on your denominator other than set it up, but all the work happens up on the numerator. So I need to clean up this numerator a bit. I have 5 times x minus 7. Good, 5x minus 35, thank you. And then there's a plus sign, and then 4 times x, better known as 4x. So I have a little bit of cleanup here. 5x plus 4x is 9x minus 35 over x times x minus 7. At the very end, you want to be careful. Once in a while, stuff will factor at the very end of the question, but 9x minus 35 does not factor. So this is a good answer right there. So in that question, you had to build up the common denominator and do a little bit of simplification. Number 3 was missed by a lot of people on the last test. So at first, y'all were happy because you saw your denominators and said, oh, I have a common denominator. So you wrote down x minus 5, and then you didn't have to do any work in order to build it up because it already had the common denominator, but a lot of people stopped here. And the problem with stopping there is that the very last step on that yellow card says at the very end, look for some extra factoring. 9x squared minus 45x. That factors. You can take out a 9x, yeah. And if you take out a 9x, you're still left with x and a minus 5. And now look what happens. You have a common x minus 5 that's going to cancel out. So final answer, 9x. So I think you guys know me well enough to know that I'm not going to give you 2 really easy questions in a section. Yeah, the first one's going to be really easy, where it already has a common denominator and life is good. But if you see another one like that on a section tomorrow, be a little leery that it might be like number 3, where you have to factor at the last minute. Okay? All right. Oop, did I skip number 4? Yeah. Sure did. Let me get a blank page in here. Can someone read to me what 4a looks like?
5 over 3x minus 1.
Thank you.
Minus x over x plus 2.
Okay. So definitely do not have common denominators. And they're not factorable. So I'm just going to go ahead and give myself a grocery list of everything that I need in my denominators. So I need a 3x minus 1. And I'm going to need an x plus 2. So this is a lot like number 2 that we just did a few minutes ago. So this fraction is missing the x plus 2. And then this fraction is missing the 3x minus 1. So you don't have to do any work in the denominator because you already have it set up. All your work happens up in the numerator. So let's start cleaning that numerator up. 5 times x plus 2 will be a 5x plus 10. Be careful here, guys. You have a negative x that you're distributing into here. Good. Negative 3x squared plus 1x. So a little bit of cleanup, collector-like terms here. It is a quadratic, which sometimes means we do have factoring. Let's see, that's a plus 6x plus 10. But I kind of looked ahead on this question. There is no factoring that's going to cancel. So the good news is, once you get this cleaned up, you're good. You're done. Questions so far? So that's all one section. That's 8-5. This is your second chance at 8-5, and this is probably your last chance for an in-class retake. Got it? Got it?
Maybe.
Maybe. Now, 8-6. A few of you were not feeling 8-6 last time. This was a rough moment. The first concept in 8.6 is, can you tell me what are excluded values? Yeah. And the idea for an excluded value is that your denominator cannot equal 0. So whatever denominators you have, they can't come out to the number 0. That would be the excluded value. So if you want, you could literally set that up. You could take your denominators as two separate problems and say x minus 7 cannot equal 0, and x squared minus 49 cannot equal 0. And if you can find any answer that satisfies either of those equations, those all get put in my excluded list. So what is this guy going to give you? X can't be 7. So I'm going to write x can't be 7. What about this?
7.
Just 7? Yeah, doesn't this give you a positive and negative 7? So we already have 7 listed, so we're good there, but also negative 7 would be excluded. Either one of those numbers would give me a divide by 0 somewhere in my problem, which means it's excluded. You could find the solutions to quadratics in that case simply by factoring. The one that's on your test is really close to this one. This one's a little more exciting than the one that's on your test. Okay, and this is where it went crazy. We are to solve. We need to identify what's called the least common multiple of our denominators. So this is the question where you put big parentheses around the whole problem, and you distribute the LCM into every single fraction. And those of you who took my advice and you wrote the LCM in front of each multiplier had a very good result on your test. So let's try that this time. I'm just going off of what worked last time, and that's what worked for y'all. So start telling me things that you see that show up in our denominator. 2 and an x and
1.
an x plus 1. Good. That's what we're going to multiply everything by. A 2x and an x plus 1. And we're going to distribute this to everybody. Now, I know this feels like a ton of work, but it paid off so much on the last test for people who did it that I would suggest all of us do this. We're going to write that 2x times x plus 1 in front of every single fraction. Do you remember what I did after this? Because if you wrote this in pencil all in one color, this is a lot to look at. Remember, we're going to cross off, but even before that, I had you box in each multiplication question. Because each one of these is a problem that you're to simplify. Alright, so now we're going to start crossing stuff off. Alright, each box, something better cancel, because that's the whole point of me doing this, is to get the denominators knocked out. So what cancels in this first multiplication?
2x.
Good, 2x, gone. So what do you have left? Times 7, so 7x plus 7. Okay, equals, what cancels in this next box? 2x again. Very good. And then plus, anything cancel over here? X plus 1s, yep. So I have 2x times 3, better known as 6x. And I'm kind of investigating the type of equation I have. I have a linear equation, so I just need to bring everything that has an x to one side and non-x's to the opposite side. So let's clean this up a little bit here, guys. We have a 12x plus 6 right here. I know you don't have tons of room. Just make it work. I'm going to bring the x's to the right. And constants to the left, so I have 1 equals, what is that, 5x? So what's my answer? Be careful.
1.
1 over 5. And I got to be a little cautious because remember that excluded value business? We didn't talk about it on this question, but if you were to plug in a 1/5 to any of my denominators, would it give you a divide by 0? So like right here, 2 times 1/5, well that's not 0. And then 1/5 plus 1, well that's not 0. So looks like our answer is going to work, so we're going to keep it. So I know that technique requires a lot of space and a lot of writing and a lot of time, but I think it's super worth it. All right, number 8. There is some factoring that you need to think about because x squared plus x, can you write those in their factoring components for me? What's another way of saying x squared plus x? You could factor out an x, so it's x times x plus 1. This is why factoring is so important. When you look at it in terms of their factors, you're going to have less things to include in your common multiple. Speaking of common multiples, what do I have to knock out? An x plus 1. Anything else? And an x. I'm going to write it over here because I don't have a lot of space. Oops. Kind of overshot that. So again, guys, I know it's a pain to write it all out, but I think it's worth it. So I'm going to go ahead and do that. So I have x times x plus 1 times the first fraction plus and then make sure you're writing the new factored form of this denominator, the x and the x plus 1. Okie dokie. So, it's a lot to look at. So let's kind of chunk it up into parts. There's a thing I gotta simplify, here's another thing, and here. Alright, lots of cancellation ahead. First box, what cancels? So we're left with 3x. And then here, oh, everything cancels. Now be careful. A lot of kids tell me 1 over 1 cancels, I'm just gonna write nothing. Yeah, 1 divided by 1 is still 1, so you still have a 1 here. And then here, you got 4. Oh, we have this. All right. Subtract 1 from both sides. Yep. So you get 3x equals 3. So x equals 1, and I'm a little nervous because of that excluded value thing. So I think about going back to my denominators. If you're to plug in x equals 1, what's 1 plus 1? 2. So the point is it's not 0, and that's the only thing that would give me problems, so I get to keep my answer. Yay. And then just for funsies, I threw a proportion on again, because some of you, oh man, what happened? Can you read me 9a, please?
1 over 5x minus 4.
Okay.
Equals 2 over 2x plus 3.
Okay. I threw a proportion on basically as a favor to those of you who are struggling with this section, because I thought, like, if anything, you could solve the proportion. Well, some of you just gave up on life last time. I don't know what happened. Guys, don't you just cross multiply? So 2 times 5x minus 4, you'll distribute that. And then 1, which is boring, times 2x plus 3, which normally I distribute that, but a 1 doesn't do anything. So the equation you're going to solve is 10x minus 8 equals 2x plus 3. Now, if you went through all that LCM work like we had been doing, you're still going to get the exact same math I'm doing right here. But you guys are very familiar with proportions. You've done them for years. All right, so we still have to watch out for excluded values. You get 8x equals 11. So x is a gross 11/8, whatever that means. And if I plug in an 11/8 here or here, I do not get a divide by 0. So I'm going to say we're good. Okay, we cross multiplied. So we did 1 times 2x plus 3, that's where this side came from, equals 2 times 5x minus 4.
Can we do that instead of doing the...
Only on proportions. So I'm going to erase this for a moment. Can you read me the question? It was 1 over 5x minus 4 equals 2 over 2x plus 3?
Yeah.
Okay. If you still use the LCM technique, you're going to get the exact same math. Because 5x minus 4 times 2x plus 3 is your LCM. And when you distribute it into each fraction, like on this first fraction, the 5x minus 4's cancel. So you're going to end up with this.
Okay.
And then on this fraction, the 2x plus 3's cancel. So you end up with this.
Okay.
So technique doesn't matter. You're going to get the same equation. The cross multiplication is just something you guys are super familiar with, so we kept it. All right, so that was 8-6. That is a retest, and that'll probably be the last time we see 8-6. I'm hoping this is the last time we see most of this test. Have not tested chart problems yet. I need you to set up the chart. I need you to write the equation. I need you to solve the equation and then label your answers. So we have Betty and Jackie, and they are working on homework. Betty can finish the homework in 3 hours, and then Jackie can finish that same homework assignment in 2 hours. So that was their way of telling me Betty and Jackie's working rate. How do you write Betty's rate if she could finish the job in 3 hours? 1 job in 3 hours is how we write that fraction, 1 over 3. So what's Jackie's rate?
Why is Jackie's box so small?
I don't know. I think I deleted a row by accident. Time. Time is how long it takes them to work together, which that's the question, right? So let's call it x. And we're going to use x for both because they're going to work together. No one sees a problem with this problem? Why are they working on homework together? You can't do that. It's rude. I don't want to hear that. All right, so this is x over 3, and this is x over 2. And then if these cheaters work together on their homework, how many homework assignments are they going to have done at the end of this?
5.
One homework assignment.
What?
They're only working on 1 job together. It's like they rip the paper in half and say, you do 1 half, I'll do the other. They're cheaters.
But that's how we do it.
That's not what I want to hear.
Actually, no, it's called being smart.
Internet, my third hour is a bunch of
Smarter
cheaters. And there we go. All right. Hope your parents watch this. All right, what's our LCM? What's going to knock out a 3 and a 2? 6. Let's multiply a 6 into everything. Don't forget the 1, guys. The 1 needs a 6 as well. So 6 times x over 3 is a 2x. 6 times x over 2 is a 3x. And then this is no longer a 1. What is it? It's a 6. All right. 5x equals 6. And what does that come out to? 1.17 or something?
Would you say it was 6
No,
over
1
5?
point. What is it?
Would you say it was 6 over 5?
You can. 1.2? 1.2. Thank you. 1.2 hours. Okay. So I need to see your chart set up, guys. That's part of the skill. I know some of you were like, I hate the chart. Well, whatever. Do it anyways. Move on to 11A. This time, Joy can create a final exam in 4 hours. When Joy and Sale work together, it takes them 1.71 hours to get that job done. So how long will it take Sale to work by himself? So what's Joy's rate? 1 job in 4 hours. What's Sale's rate?
1 over x.
Good. Keep the same format, 1 over x. That way when you find x, you know how long it took him to do it by himself. How long does it take them when they work together? 1.71, thank you. And then the math works out the same way. You multiply across the row. And you don't do any actual math yet, guys. You just set it up. So 1.71 over 4. And this is 1.71 over x. So when we add together each person's work, they should have one job done. So 1.71 over 4 plus 1.71 over x equals one job. What's my LCM for this question? Good, 4 and an x. So I'm going to need a calculator on my second fraction here, but 4x and over 4, the 4's are going to cancel. So you get 1.71x plus, this is where I need a little calculator assistance. The x's are gone, but what's 4 times 1.71? 6.84? You smiling when you say it, okay. And then is this a 1 anymore? Ah, it's a 4x. There you go. This is the most common mistake on this question, guys. The kid who writes something other than 4x at the end. All right, so we're going to subtract 1.71. Please don't trust your brain to do the subtraction of decimals. No offense, but my brain doesn't do it right either. All right, so 6.84 over...
5.1.
No, we're subtracting.
3.
Well, you're just saying things now. 2.29 divided by 2.29. And then what'd you get? Should come out really close to a whole number is my guess. Or not.
2.98. So
It's like really close to 3 hours. Yeah. So if you wrote 2.98 hours, I'm good with that. If you said about 3 hours, I'm okay with that. Because what I'm really grading, guys, is everything before that point. So, all right. That should be an easy 5 for us, yes?
yes.
Yes.
Sure.
Sure.
Hopefully.
Oh, talking about easy 5s, let's knock some out right here. Permutation and combinations. When do you use a permutation versus a combination?
In the order, man.
Okay, which one's that?
That's a permutation.
That's a permutation. All right, so when we're ordering, what's another buzzword for permutation? Arrange.
Group.
No.
That's a combination.
Assign. Sometimes they don't say the word assign. It's like implied. So you have to watch out for assign. So what kind of words do you see for combination?
Group.
Committee, I heard. Sometimes group, yes. Team is a big one. So when order doesn't matter because you're just selecting people or things to be in a group, yes. So how many ways can you arrange 6 students at the door? What do you got, guys? Permutation or combination?
Permutation.
This is a permutation for sure. Now there's other ways to calculate permutation, so how you calculate it is up to you, but please, guys, do me a favor on your test. Write down on your paper whatever you typed on your calculator, because I can give you a better score if you mess up, if I see what you did. So 6 permutations is 6. If you chose another way, that's fine. What? Okay. Yeah?
Yeah, that's right.
Okay.
Gavin did it in his head.
Yeah, you did 6, 5, 4, 3, 2, 1. That's fine. Because that's the same thing. You could do factorial. Permutations are the weird ones where you can do them multiple ways. So as a student, I just do whatever is easiest. So up to you. How many ways can you select a team, keyword team, of 6 students from a class of 35? Okay, combination. And how do I type this? You put the total first. So out of 35 kids, you're choosing 6. Now, if you hit the wrong button by accident, but you write... Okay, here's the thing, guys. Most common mistake, kids literally just type the wrong button. It's very frustrating. So if you wrote this on your paper and you gave me an answer that didn't say that, like you accidentally hit permutation, I'm still going to count you right. So show your work. What is this, by the way?
1,620,160.
Eh. 1, 6.
2, 3.
Thank you.
160.
Thank you. Thank you for your attempt at all the digits. You said it right. When you all talk together, it's confusing. All right. Now, guys, if you did permutation by accident, you'd get a giganto number. It probably would be overflow. How many meals can you create? Oh, why did I do that for you? That was a B. Oh, for Pete's sake. All right. 13A. How many meals can you create if you have 5 appetizers, 6 entrees, and 4 desserts?
You were going to give us a hard one for B.
That wasn't hard. Why was that harder? Because it's in the millions? You didn't even do the math. You just type buttons. Come on.
Just saying.
All right. Now, guys, this is neither permutation nor combination. This is a counting principle question. How many decisions are you making?
3.
Yeah, you're making 3 decisions. You're choosing 1, 1, and 1. So 5 choices for your first decision, 6 for your second decision, and 4 for your third decision. And that's all you got to type. Again, show me your work, and then I can give you partial credit if things go wrong.
120.
Thank you.
Oh, I did that on myself.
That was dangerous. Thank you. All right, I'm totally skipping 13B. You do it yourself. You're going to get a 5 on that section, yes?
See?
Yes. I hope not.
All right, this question. Oh, this question. Oh, yeah. All right, guys. So, this question is horrible for me to grade. Or it's really easy for me to grade. There's certain things I'm looking for. So, I want to describe a situation that you would require a survey. So, someone give me an idea of what would you possibly need to survey people for? Okay. So, like the SAT test? Okay. So, let's broaden our population a bit. So, number of juniors who studied for the SAT. Now, here's the key, guys. I want to know, how are you going to distribute the survey to a sample? So, by me saying sample, you cannot tell me, well, I'm just going to give it to every single junior, because that's not a sample. So let's say I only have 100 pieces of paper. That's all I have. Alex, how would you distribute the survey, making sure that it's random and unbiased in the way you distribute it to those 100 kids? Okay, yeah. Did you hear her? She, buzzword, random number generator. Can you give me more about that? Like, what would you do? I have 460 juniors right now. How do I pick 100? So, like, I have a list, I have an alphabetical list of 460 kids. Or you want to group them by advisory? Okay. All right, so how are you going to choose, let's say, there's like 20 kids in every advisory. So, whatever I just said. So, you can choose 5 advisories. So, you label each advisory a number. And then you use a random number generator to select 5 of your advisories. Perfect. There's like, I basically grade these like a robot would. I look through it for key buzzwords, and random number generator is like the number 1 thing I want to see. It's just random number generator, blah, 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 and blah, blah, blah. It's one of those situations where you just write a lot, and hopefully something sticks, okay? Just, are we clear? If you're giving it to a sample, you can't tell me I'm giving the survey to everybody. That's not a sample. And you have to somehow randomize it. And it's obviously unbiased because Alex has no idea who she gave it to because the computer chose advisories that way. Okay? All right, so how about this one? For a stats project, a group of students wants to want to know how many, okay, stats kids, they want to know how many kids want to get a summer job this year. Decide how they should give out the survey to sample students, how could they distribute it. So that question right there is just like what Alex just said. If you're only going to give it to a sample of students, she suggested advisories, giving each advisory a number, and then having a random number generator select how many advisories you were looking for. Very good. How would you bias that? Okay, somehow you know who the smart people are.
You can always do
Based on grades.
Okay. Somehow I know where all the...
Give it to boys.
Okay, well, how are your advisories grouped? By ages, right? 10th, 11th, and 12th graders? So what if I gave them to a bunch of 10th graders? Is that a group of kids that typically has summer jobs?
Nope.
Not really, because some of them can't drive yet.
So C.
Yeah. So the problem with that is, like, I don't want to bias the results, but guys, there might be a question on your test tomorrow where the way I distributed the survey is very biased. Can you pick that out? That's my question tomorrow. So if I only gave that survey to sophomores and not a good selection of everybody, the idea, guys, is your sample has to be representative of everybody in your population. So if your intention is to find out how many high school students at Harlem are going to get summer jobs, and I only hand the survey to juniors, that's not a good selection. Or only to sophomores, it's not a good selection. But if I give to some sophomores, some juniors, some seniors, then it's a more representative selection. All right. You guys will do fine on that question. I'm not worried about it. Oh, the chart. Got your highlighter handy? This is where we use highlighters. Can you tell me when my denominator is not the 128? When it tells me what? Very good. So this question and this question, you're going to have different denominators. But on these other ones, your denominator is going to start out as 128. So that's the first thing I do when I hit these questions, is I figure out which one has the weird denominator because they've selected just a part of my data. And Gavin was right, it's the givens. All right. First one, probability that you select somebody who is normal weight and female. So when they use the word and, you're just looking for one number off that chart. Go find that one number that represents everybody who's
14.
Normal weight and female. And I heard 14. Very good. Now guys, can you reduce that? Yeah. I don't really care if you do. I just want to see your setup. Okay, be careful with the or. The or problem is where you find the number of male plus the number of underweight. But then we have to subtract off the males who are underweight. Why do we have to do a little subtraction here? Yeah, we counted them twice. So here's all the males, 68. And then here's all the underweights, 30. But think about this, guys. If you took all the males, all the underweights, you counted these dudes twice. So you have to subtract 5. What was it? I'm sorry. 93. Thank you. So I ran out of room, but this is 93 out of 128. And then for the given one, what is my denominator if it says given male? Yeah, and this is the one where if you have a highlighter, you might want to use it. So I'm only looking at, whoa, that got weird. Okay. These guys. So that's why you guys are telling me a denominator of 68. Thank you. Now, out of just this data, what's the probability that they are normal weight?
18.
Good. And then again, if you guys want to reduce your fractions, you sure can. All right, I got one more question. It's a reader. Get your reading glasses on. Ready? Bifocals. Your super glasses, it's fine. All right, so the theater company reviewed 3 surveys of pizza preferences. One survey reported that out of 120 students questioned, 45 preferred Papa John's. A second survey noted that 30 out of 101 people like Pizza Hut, and then we got 23 out of 63 like Domino's. So we have Papa John's, Pizza Hut, and Domino's. Now, those fractions aren't really nice for my brain to think about, so maybe we can convert those to percentages. So for Papa John's, I have 45 out of 120. Can you guys convert that to a decimal and then eventually a percentage for me?
Yeah.
What you got, kiddo? 38%? Is it exactly 38? Wait, what? Oh boy.
It's 337.5.
So 37.5? I'm keeping at least a 10th on the percentage because if one's like 37.5 and one's 37.9, like rounding them both 38 would be confusing. All right, Pizza Hut is 30 out of 101. So that should be about 30%, but what's exactly is it?
Yeah,
29.7, thank you. And then Domino's is 23 out of 63. It's 33, 30 what?
6.5.
Okay, thank you. So read carefully, guys. It says you need to choose 2 businesses. Which one would have the best results? Basically, we want people to buy our pizza. So which 2 are the most popular?
Papa John's and
Yeah. Papa John. Whoops. Okay. Because they have the highest percentages. That's why. You don't have to do any explaining on that question, guys. But trust me. When you write out these fractions and percentages for me and then I can see why you're choosing those 2, like, if something goes wrong, this is the only way I'm going to be able to tell. All right, thanks.